Good day, grade 9s. This week, we are going to look at algebraic equations and how to solve them. But before we do that, I just want to remind you again of what the difference is between an expression and an equation. Always remember, an expression is like an instruction. You are being instructed to do something and there must be a result, and in the case of an expression you must get an answer. So for instance, an example is if you have to simplify 3x plus 5x, the instruction is inherent in the expression. It literally means you have to take 3 times a number and add it to 5 times the same number, and then we can do that because it's the same numbers, it's like terms, and I can say 3x plus 5x is 8x, and I got an answer and it is done. That is an expression. An equation is very different. An equation is a mathematical statement, and it's a comparison of one value to another, or one expression to another, and it has a left-hand side which is equal to a right-hand side. It must always be equal, and it must always stay balanced. So an equation can have an expression on the left-hand side that is equal in value to the expression on the right-hand side. For instance, if I take the same expression that we used just now, and I say 3 times a number plus 5 times a number must be equal to 24. I now have an expression on the left-hand side that must be equal to an expression on the right-hand side, or the two values must be equal. So we don't get an answer for an equation. We solve it by saying, what must this number be that I must add together to get 24? What is the unknown value in this equation? So to do that, in this case, because it's like terms, I can simplify the left-hand side, and I can say the left-hand side is equal to 8x, and the right-hand side, it must be 24. So 8 times a number then must be equal to 24. And because you are so clever, you know that the number that you must multiply with 8 to get 24 must be 3, and that will be the solution. So that number, x, must be equal to 3. And 3 is the solution, and we also call it the root of the equation, because 3 will make the left-hand side equal to the right-hand side. And then we can do a small test. We can see whether that's true. We can look at the left-hand side and say, if x is 3, then it means that 3 times 3 plus 5 times 3 add up to 9 plus 15, and that is going to add up to 24, which is equal to the value on the right-hand side, which means that x equal to 3 is the root of the equation, or the solution. So that is what we do when we solve an equation. So for this, our first exercise, we are not going to use mathematical methods at this stage to solve the equation. We are going to substitute. We're going to use values and substitute it in an equation, and then we're going to see which of those values will make it true. So we're starting with revision. You have done this in term 1. We're going to solve linear equations, and then we're going to test the correctness of the solutions. But for the first example, we're going to solve each of these 2 equations, but we're going to substitute values into the equations to see which of those values will make it true. So given is values for x. X can be negative 3, or it can be negative 1, or it can be 1 or 3. So we're going to test and see which of those values will make the left-hand side of this equation equal to the right-hand side. And we're going to do that by substituting that values into the equation. So let's do that. So for my first one, my equation is 2 times the number plus 14, must be 20. So if I take my first value for x, which is negative 3, and I substitute it into the equation, I'm going to get 2 times negative 3 plus 14 is going to be equal to negative 6 plus 14, which is going to give me 8. And can you see that 8 is not equal to 20? 20 is the value on the right hand side. So that is not equal to the right hand side, which means that x equal to negative 3 is not a solution to my equation. So if I now try the second value for x equal to negative 1, I'm going to get 2 times negative 1 plus 14, and that is going to give me negative 2 plus 14, which is going to give me 12. And once again, can you see that 12 is not nearly equal to 20, so it's not equal to the right hand side, which means that x equal to negative 1 does not solve my equation, it's not a solution. So let's try 1. So I substitute 1 into the equation, plus 14, and I get 2 plus 14, and that gives me 16, and it's still not equal to the right hand side. So the third value that I've been given, x equal to 1, does not solve my equation, so it doesn't work. So hopefully the last one will work. So I go to x equal to 3. I substitute it into the equation. I get 2 times 3 plus 14. And I'm going to get 6 plus 14. And at last, you see, I get 20. So 20 is equal to the 20 on the right-hand side, which means that x equal to 3 is a root of the equation, or it's a solution, and it's my answer. I have solved that. X must be 3. Let's look at another example. Once there's my second equation, and I must use the same value. So I must start with the first one. If x is negative 3, what is different in this equation is that I have a variable on both sides. So for this one, I'm going to see what the answer will be on the left-hand side. First, I'm going to substitute on the left-hand side, and I'm going to get 4 times, if x is negative 3, minus 3, and I'm going to get that the left-hand side is equal to negative 12 minus 3, and that will give me negative 15. So I know what the value on the left-hand side is going to be. So what happens on the right-hand side? If I substitute the x into the right-hand side, on the right-hand side, I have negative 18, and I subtract negative 3. So that is going to give me negative 18 plus 3, which is going to give me negative 15. Can you see that the left-hand side is equal to the right-hand side? Therefore, I've somewhat found my solution very quickly now. Therefore, I can say that the left-hand side equals the right-hand side, and for x equal to negative 3, and that negative 3 is a root of the equation. Right, that is the one way that we can do equations, but I think you can see that this can take very long. If you are not lucky, you can sometimes have to substitute a lot of values to find the solution. So we are now going to look at mathematical solutions. Right. So if we solve equations mathematically, there's a few things that you have to keep in mind. I've summarized it here for you. The point of solving an equation mathematically is that I want to isolate the variable, the unknown. And I'm always going to end with an answer that says x must be equal to a constant or a value, so that I can say that is the root or solution of my equation. To do all of that, we use inverse operations. In case you have forgotten what that is, the inverse operation of addition is subtraction, and the inverse operation of multiplication is division. And then the big rule for equation, it must always be balanced. The left-hand side must stay equal to the right-hand side, and from that we get the rule. You all know that rule. What you do on the left-hand side must be done on the right-hand side. So example 2, we're going to solve for x, and we're going to use mathematics. Right, so my mission with an equation is that I want an answer at the end that says x equal to 0. So I want the unknowns or the x alone on the left-hand side and a value or an answer on the right-hand side. So if I look at this equation, I have two terms on the left-hand side equal to 0 on the right-hand side. So the right-hand side is very simple. But on the left-hand side, I must first solve or simplify the left-hand side, which is an expression. And the left-hand side, I have to multiply 5 with the bracket, minus 3 with the bracket. So we're going to distribute. So let's do that and see what we get on the left-hand side. Let's distribute 5 into the bracket and negative 3 into the other bracket. Then we get 5 times 2x is 10x. Plus 5 times 1 give me 5. Negative 3 times 2x give me negative 6x. And negative 3 times plus 3 give me negative 9. And on the right-hand side I have 0. So I simplify further because here I have like terms. I can add 10x and negative 6x. That will give me 4x, 10x minus 6x. And I can add 5 to negative 9, which is going to give me negative 4. And all of that must still be equal to 0. So I want to isolate the unknown. The term with the unknown is this term, 4x. I want it alone on this side, which means I don't want minus 4 here. So now I'm going to use inverse operations. To get 0 here or to get rid of negative 4, I'm going to add 4 on the left-hand side because negative 4 plus 4 is going to give me the 0 I want here. But now remember, an equation must always stay balanced. So if I add 4 on the left-hand side, it means I must add 4 on the right-hand side. So now it's balanced. So on the left-hand side, I'll be left now with 4x because the negative 4 plus 4 give me 0. And on the right-hand side, I'm now going to have 0 plus 4, which is just going to give me 4. I still haven't got the unknown, the x alone. I have 4 times x here. So again, I'm going to use inverse operations. The opposite of multiplying with 4 is dividing by 4. So I'm going to divide 4 on the left-hand side. And what I do on the left-hand side, I do on the right-hand side to balance the equation. And I'm going to get that 4 going to 4 ones on the left-hand side. And 4 going to 4 once there, and here I'm just going to get 1x equal to 1, and my equation is solved. Thank you very much. That is it for today's lesson. Hope it helped.